This is a Section 1.3 Mathcast. It contains 3 lessons. Students will encounter 2 measures of relative standing. Percentiles using cumulative relative frequencies and ogive graphs to compare the relative standing of data points within the same data set. And z-scores are used as a way to compare relative standing between measurements from unrelated distributions of data. Finally, the effects of linear transformations of data upon summary statistics of center and spread is explored. This entire section is a foreshadow of chapters 5 and 6, where the ideas will be revisited and used extensively. Students will use ogives as a function to determine percentiles given a measurement, and as an inverse function to determine measurements given a percentile, including finding medians and quartiles to make box plots. Lesson 131 includes problems that begin with a histogram and require finding cumulative relative frequencies and then constructing an ogive. Also, problems that start with an ogive and require working backwards to create the histogram. You might wish to practice these techniques before the lesson to increase your comfort with them. Here's a change of 3, and another change of 3, and a change of 2, another change of 2, here's a change of 1, some zeros, and finally another change of 1. Lesson 131 is designed to have students conceptualize percentiles using cumulative relative frequencies and ogives, while avoiding the myriad of empirical rounding rules for calculating them from small data sets. The concepts in Lesson 131 tie directly into understanding probability density functions, which are referred to directly in Chapter 5 and tied to every concept beyond. Lesson 132 continues the escape in Minneapolis activity, where z-scores are used to make comparisons of data points from different distributions. You need to be comfortable performing and explaining z-score calculations. It's important to realize here that z-scores are presented as a way to compare data points from different distributions. And because they are unitless, they're critical for the derivation and exploration of the characteristics of the coefficient of correlation and coefficient of determination found in Chapter 2. Z-scores are presented independently of the empirical rule and the normal probability density function, but return with these concepts in Chapter 5. Review Preview Problem 1-69 may seem a little tedious, but it is a preview for exploring the concept of degrees of freedom for two-way tables. If these totals are assumed, and this number of values here are allowed to be anything, or are free to vary, these values could be fixed in order to compensate to make the totals true. Lesson 133 leads the students through some situations demonstrating that transforming data via multiplication will affect measures of center and spread by the same factor, while transformation by addition or subtraction does not affect measures of spread. Lesson 133 includes a math notes box explaining why statistics uses y equals a plus bx for one variable transformations rather than y equals mx plus b. Some of your students will need repeated reminders to use the correct notation, so start early. Linear transformations on data and their effects on descriptive statistics are fairly intuitive, but do not skip this lesson. The concept of a random variable is subtly introduced in problem 1-71. And all of these ideas presented here are needed again in Chapter 6 lessons involving transforming and combining random variables. These 3 lessons represent a very important preview of concepts found in Chapter 5 and Chapter 6.